So welcome to class 14, solving exponential equations. This is our next topic in our exponential unit. And if you picked up your packet from school, you can see that today is Tuesday the 12th, and we're looking at Black class 14, solving exponential equations. So I anticipate that class 15 is going to be a review of the unit. And then on the 18th, you're going to have some type of assessment, either two choices, or what I've been doing in my classes is half of it being free response and half of it being a video conference with me. So look for that. So on Thursday, you're going to have to probably sign up for a video conference with me, which will kind of last during this week. Or if I can come up with two different choices for your assessment, I will do that. But we're looking at an assessment next week and going into a new unit about sequences starting the 22nd. So here we are. We're on page, I say 23 of your packet. And if you don't have your packet, then you just click on the Google Doc. So you're going to be filling this out as your class notes. And I just have 6 quick checks for understanding questions at the end. So this is more notes for you. And then we're going to go through this together on the video. And then we're going to go all the way up through number 17 together. And then you're just going to complete 1 through 5 and send 1 through 5 in a picture to me. All right, so these first few questions we actually talked about way back at the beginning when we talked about that table of powers. So all the powers of 2, all the powers of 7. So you can look back at that table of powers, or you could just think to yourself, 2 to what power will give me 32? So if you're not sure, you can actually do it in your head. We know that 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16. That makes 2 to the 5th 32, because each time you're just multiplying by 2 again. So in this first problem, our solution must be 5, because 2 to the 5th is 32. I can also check that answer or do some guess and check on my calculator. The exponent button is this caret symbol. So 2 to the 5th is 32. So I'm verifying that it's correct. So 7 to what power is 49? I think we all know that 7 squared is 49. And 3 to what power is 81? So this is, again, you can use that idea of a power family. We know that 3 squared is 9, and then 3 cubed is 27. So that makes 3 to the 4th 81, because each time you're multiplying by 3 again, and you can check, yes, 3 to the 4th is 81. So our answer, x, would have to be 4, so that 3 to the 4th power is 81. Remember, you're solving for x in these problems. And then 5 to what power is 125? Well, 5 squared is 25, so 5 cubed is 125, because I'm just multiplying by 5 again. So the answer here is 3 for 5 cubed. So that is the first strategy when you're trying to solve an exponential equation, is to just look and see, is this a quick, easy power family question? Part B is a review of our exponent rules from 2 classes ago. And if you haven't taken your quiz yet, or you need to retake your quiz, this will help you review some of those exponent properties. So the first property is called just the product property. And the rule is that you're allowed to add the exponents together, so you would get x to the 9th. The reason that you're adding the exponents together is because if you wrote out x to the 7th, x to the 7th would look like that, 7 x's in a row. X squared would look like that. So you really have 9 x's in a row. So that's represented by x to the 9th power. Multiply x by itself 9 times. Number 6, this is the power property. So I have an exponent here, and it's being raised to the power of 2. The rule is that you multiply the 2 powers together. So this would be x to the 14th power. That's because you really have x to the 7th times itself, x to the 7th. And now that they're written as a product, we know that 7 plus 7 would give me 14. So this again is the power rule. So I get y to the 15th because 5 times 3 is 15. And this again is the power rule. So I could just leave it as x to the m times n power. Part C. So this is something called the one-to-one property. So the one-to-one property is when the base is the same on both sides. So 4 and 4, 6 and 6, 2 and 2, 8 and 8. I can use the one-to-one property because the base is the same on both sides of the equation. When you have the one-to-one property, what you're allowed to do is just equate the two exponents. So if the bases are both 4, then the exponents have to be equal to each other. So in this first problem, x has to be 3 to make this equation true. All right, I have 6 and 6. So if the exponents have to be equal to each other and x plus 1 has to equal 5, then what does x have to be? If I subtract 1 to the other side, I get that x would have to be 4. Doesn't that make sense that 4 plus 1 is 5, so 6 to the 5th equals 6 to the 5th? Number 11. They're getting a little bit more challenging, but I know that my base is 2 on both sides, so I'm going to take my exponents and set them equal to each other. So 3x minus 1 equals x plus 5. So now I need to solve this linear equation for x. So it's a good review of your linear algebra skills. Subtract x to the other side. We want to get our like terms together. So now I have that 2x minus 1 equals 5. I'm going to add 1 to the other side. So 2x equals 6. Divide by 2. X has to equal 3. So let's check if that makes sense. If I plug 3 in here, 3 times 3 is 9, minus 1 is 8. So this represents 2 to the 8th. If I plug 3 in over here, I also get 2 to the 8th, because 3 plus 5 is 8. So it should make sense that x is 3 will make these equal to each other. So this last one, I have the same base, 8, but on this side, I need to do the power rule before I set my exponents equal to each other. So this power is actually 2 times x plus 3, and I need to distribute the 2 to the x and the 3. So this exponent is really 2x plus 6. And the other exponent is 3x minus 2. So I'm going to set them equal to each other. Subtract 2x from both sides. 6 equals x minus 2, and then add 2 to the other side. So x must equal 8. So now it says, what if we need to actually change the base? So unlike here where we had 4 and 4, 6 and 6, we could use the one-to-one property. We're starting out with something that does not have the same base on each side. So it says you could guess and check, but that may take a long time when the bases aren't the same. So here's a technique to use for these types of problems. So here's my original problem, that 8x equals 2 to the 6th. So we want to replace the higher base, so 8 is bigger than 2, replace the higher base with the lower one and an exponent. So can't 8 be equal to just 2 cubed, right? Isn't 2 cubed 8? They're equal. So I'm just replacing the 8 with 2 cubed. So now I have 2 cubed raised to the x power equals 2 to the 6th. So this is like the problems in part A above. You had to think of a power family for this step. Part B, simplify the exponents. This is like part B. What's our exponent rule? I have to take 3 and multiply by x. So this is really 2 to the 3x power. Step C, because the bases are equal, the exponents have to be equal. So solve the equation like in part C. So I'm going to say 3x has to equal 6. 3x has to equal 6. Divide by 3 on both sides. So x has to equal 2. And then check your answer in the original problem. So this is the most complicated, but doing each of these individual steps should help you understand how to do it. So we are going to do 13 through 17 together, and then you're going to submit 1 through 5 as your check for understanding for today. So let's see. Example 13 already has the 1-to-1 property, a 3 on both sides. So I can just set my exponents equal, and x must equal 4. Number 14, I have 2 on both sides. So I can set my exponents equal to each other. X plus 1 equals 2x minus 3. Subtract x. So 1 equals x minus 3. Add 3 to the other side. So x must equal 4. Just a coincidence that they came out the same, completely different problems, but x would equal 4 again. Number 15 and 16. We have to replace the larger number with the smaller base. And 32, we know, is 2 to the 5th power. So I write it as 2 to the x equals 2 to the 5th power. I haven't changed the amount on this side, just the form. So x must be equal to 5. All right, getting a little bit trickier. So I have 1/4 on this side, and I have 16 on this side. So actually what I'm going to do is I'm going to turn these both into a base of 4, because that is the power family that they share in common. So 4 raised to what power actually is 1/4? It's the negative first power, because the negative exponent flips it over and would make it 1/4. So I have 4 to the negative first, and then all in parentheses raised to that original x. And I know that 16 is 4 squared. So I haven't changed the value. 4 squared and 16 are the same number. 1/4 and 4 to the negative first are the same number. So now I use my exponent rule. 4 to the negative x equals 4 squared. I set my exponents equal to each other. Negative x equals 2. Divide by -1 on both sides. So x must equal -2. And then the last problem, this is a little bit trickier. How are you going to get 1 on this side? Remember, anything to the 0 power gives you 1. So this exponent, 2x plus 3, must be equal to 0 in order for 4 to the 0 power to equal 1. So to solve this equation, I would subtract 3 to the other side and divide by 2. So x would be -1.5 or -3/2. So you're going to go through questions 1 through 5. They all have similar process to the examples that I just completed above. You're going to take a picture of 1 through 5 only and send it to me via email or Remind. And you're going to make sure that you either retake your quiz from class 13 or take it for the first time so that you don't have a 0 in PowerSchool. Oops, and let me know if you need help. Have a great day.